Good morning.
Morning, everyone. If you've not given any comments yet about this exercise number 4, we're going to talk here for a minute or two, and you can feel free to add comments there. It's sort of good to see that there's no problems. But if you're having problems that you are not willing to share on the screen in front of everyone, you can of course come and talk to us at the break about those issues. Otherwise, do let us know, especially if there are things like confusing wording or other sort of technical issues with the exercises. Those are really useful things for us to find out about and be able to fix.
Yeah, we heard that at least the exercise sessions went relatively well, so glad if you are all familiar with functions now, how to create them, how to create your own modules. Of course, it was quite a simple exercise, but those are the basic components of functions and modules, so we can then build on top of that.
Yeah. Were there any questions or things like that that weren't necessarily a problem, but just questions from the exercise?
Yeah, maybe one point was that when you import the module, you don't have the py, you just have the name of the module, and then from module name import these and these functions. So just to know the syntax in there.
But,
Great.
okay. Yeah, if there's not any questions, the one thing from exercise 4 that we will maybe comment on a little bit was problem 0, because you were asked to give us some feedback, and we have put together a little summary here of the feedback that was given, and maybe we could just highlight a couple things that are here. This is a public repository on the Geo-Python 2019 GitHub, so you can go there, of course, yourself and get this feedback, and there's even a little thing that Volko included for making word clouds using Python, so you can maybe look at least briefly at one of the examples, and you can see if you might want to take the code and make your own word clouds.
Yeah. So we had these open-ended questions for you. How's it going? Pace of the lessons, content of the lessons, exercises, any suggestions. So all in all the feedback was super positive. So thank you for that. And of course, there were many great suggestions in terms of details on the web pages or pace in the lesson. So we have heard those. So I checked the feedback yesterday evening. If you added something today, we'll check those later. So I think the forum is now closed, but of course we always are keen to hear if you have any suggestions. Then, for example, like the Git lesson that was a bit rushed towards the end, we learned a lesson there as well. Maybe the way to do that would be to show it here, and then you would do it hands-on in the smaller classrooms, for example, because people have different experience with working with the command line and such, and different operating systems maybe. So
yeah, and I think with respect to the pace for the course, those of you who have had some programming experience before commented in many cases that you felt the pace was perhaps a little bit slow. For those who are being introduced to programming for the first time, the comments were saying the pace was about right, or sometimes even a bit quick. So the kind of target audience for the course is people that have not had any programming experience previously. So if you have, of course, that's to your advantage, but it means that in terms of the pace, perhaps there will be times when you feel like things are not progressing as quickly as you might like. And in those cases, we would encourage you to ask us questions in Slack if you want to know more advanced things. To the best of our abilities, we will try to answer questions if you want to know the details of what we're doing, or how something from some other programming language might work similarly or differently in Python. Those are really good questions to post to Slack, or you're also welcome to ask, like when we're sitting here in the classroom, if you have questions you feel you would be willing to ask in front of the bigger group. You might put us on the spot to try to answer some of them, but it's good way to make sure that like you feel you're still getting as much as you can out of the course.
yeah, many of you like the optional tasks, so if you want, you can challenge yourself, and there's again one for this week there. And of course the internet is full of tutorials, Python exercises and such, but in this course we try to kind of structure those basic elements for the beginners. So we have now 90 students still active on the course, and we hope that 90 students actually finish the course, so then that you don't get overwhelmed and drop out because it's too intensive already starting at week 2. So
maybe the one other thing we could mention just is about the course environment. There's perhaps it's becoming more and more clear as we go on in the course how all the different pieces come together, but we understand that when we introduce Git and GitHub and GitHub Classroom and Slack and all of these different systems and different websites that we're using for the course, that it can be a little bit confusing to sort of know what to use and when and how things are going to operate. So yeah, I mean, we're sorry if there is confusion. We have done our best to kind of select what we think are really useful tools, like Slack and GitHub are things that a lot of software, people who are dealing with software regularly, they're using those tools in their everyday lives as professional software developers and things like that. And they're good tools for us to learn as sort of new programmers because there's reasons that those tools exist. So although it's a bit confusing in some cases, we are sort of trying to incorporate using tools that are actually used more broadly by people who make software for their career.
Yeah, and some were commenting on the use of Jupyter Lab or the notebooks, and we have chosen to use that approach, kind of to focus on the scientific data analysis workflow and to have the space to describe your methods and to run code in small blocks. Then of course, as we get more advanced, you might then start using also different development environments. So yeah.
But thanks again for the feedback. It's really excellent to have, and we really appreciate it.
Yep. Okay. Yeah.
Do you want to show a word cloud?
I'll show a word cloud. So I yesterday spent too much time, or didn't spend too much time nicifying these. So if you want to check, there are some ways in which I try to summarize all this mass of feedback. So for example, for the question 1, what is the pace of the lesson? So you can see, so the biggest word is the most frequently used word. So mostly it was about, right? Of course, some were saying that it's too fast. There might be, or then there could be faster and these sorts of things. But of course, as you put everybody's feedback into one bunch, it's kind of a mess of everything. So you can check, and there's the source code for doing these kinds of things in the repository. So that goes then to natural language processing that some of you might find useful later on. Okay, shall we continue with the lesson, or do you have anything else to add on these topics? Dings. No more comments on exercise 4. That's great. Okay. There we go, and maybe somebody's following Slack if there's any problems with the video stream or the audio, so we'll try to react there. So today we'll start with data analysis. Good question. Yeah. They should be, and they are. Are you on CSC notebooks now?
Yes.
When did you launch your instance?
Just now.
Just now. Yeah. Okay. Let's.
I noticed this morning for some reason on CSC notebooks that when I first launched my instance, that for whatever reason it was not showing the lesson 5 notebooks. If that is the case, what I did is I just pulled the changes, but the problem is that it will then want to overwrite changes that you've made in the earlier lessons. Maybe we can work on a.
Let's see. So who all have already opened CSC notebooks, and who can't see lesson 5? Cannot. So there's who can see them. Okay, so some and some. Maybe we can spend a moment. Maybe we can now, just for the lesson, use Binder. So that means that you can follow the lesson, do the coding, and then if you want, you can save the notebook. But anyway, all the kind of real answers will be then available on the web pages. So I'll show how to do that in a bit. Okay? Yeah, but
Yeah,
maybe
so-
like just to get us introduced, so the overview of today's lesson, so we'll indeed introduce Pandas, which is a module for doing data analysis in Python, and we'll be focusing on that for the whole lesson. I'll start and then Dave continues after the break. And then we have a little exercise and we'll basically cover kind of the starting point of a data analysis workflow. So of course we need some data. We'll be working with some weather data. We'll read in the data. We'll check some properties of the data, basic descriptive statistics, do some basic calculations, and then write some output to a file. So this is still kind of very like the first steps of a data analysis process, and then we'll continue next week with more advanced data manipulation, aggregations, and analysis steps using Pandas. Great. So Pandas, that is kind of, it's relatively new. I think it was developed in 2010, a package for data analysis in Python, and the whole point of this package is to make data analysis in Python kind of easy and intuitive. So there are also other packages which you can use to manipulate numerical data in Python, such as NumPy, but then there might be a bit more steeper learning curve when using those. So Pandas is, well, I'll repeat it quite a lot that it's easy to use. There's of course more difficult tricks that we'll introduce to you, but basically I bet all of us have used Excel sheets or some kind of tabular Google Sheets data. So if you think about data which has columns and rows, with some column names and maybe row indexes. So that's the type of data that we'll be analyzing with Pandas, either the whole data frame or then individual columns. So data which has structure can be then a tabular two-dimensional structure we can read into Pandas. So for example, as a GIS person, I would think of the attribute table of a spatial layer as such a tabular example of a tabular data, and indeed then during period 2 we will manipulate some spatial data attributes using Pandas, and then GeoPandas, which is then extension to this basic module. And maybe kind of the most useful thing is that whichever data format you have, somebody sends you an Excel sheet or CSV file or JSON or some other, you read data from some web interfaces, you can put pretty much any format of tabular data into Pandas, and then there's some little parameters we need to be aware of when doing this. But most often we, at least in this course, and hopefully you also, when doing data analysis, will be working with CSV files, so tabular data that is often comma delimited or then semicolon or some other standard delimiter in a text file. Okay, so let's start with the lesson now. If you yet didn't manage, I'll now then try to demonstrate how you can, if you didn't find the lesson notebooks on CSC, then click on the student binder, open it in a new tab. It might take a moment to launch, but it should work, and maybe Dave and Lotta can have a bit of look if somebody's having problems with this. So you can raise your hand or get the attention of Lotta or Dave if you can't get the notebook open. It takes a while when it launches it for the first time, but then afterwards it should be faster if you go and launch it again. how's it going? Who's still waiting for binder? Otherwise I can continue. Be brave. Is anybody waiting for binder to launch? No? You are, yeah. Let's wait for it. Maybe while we are downloading, I think now mine came. So during this first part of the lesson, we'll get to know the basic data structures in Pandas. So far we have been working with lists, right? And then individual variables of different types of Boolean, integer, character strings. But now we add a bunch of new vocabulary and new data types. So we'll be working with Pandas Dataframes. So that would be the kind of tabular data object, and then Pandas Series, which is then one column or one row of the data. So here we have a rather nice visualization authored by David Whip of the structure of the Pandas data structure. So on the left side you see examples of how a Pandas data frame would look like. We'll be soon reading in the same data to Python. So as described, there are columns with column names, then there are rows with an index value, and then there are the actual values of each row and each column in there. And you might see different representations of the same DataFrame object. So sometimes it looks like this if you print it in standard Python, and then Jupyter kind of niceifies the way in which a data frame would look like in there. And then indeed, if we take an individual column, that's a Pandas series. So again, there are the values, it has a name, and then there are these index values. So I often explain Pandas series that it's a list-like collection, but it's kind of it's like a smart list. So there's some sequence of values, but then Pandas series have a bit more variety of methods we can then use for manipulating the contents of that so-called list. Bit more annotated view of the same thing. So indeed, we have labels for the columns, we have index for the rows, we have the values in these, we can call them cells or locations in the data frame, and similarly for the Pandas series. And we'll find out sooner, it might be not super clear yet, but also this kind of column label or then row label, they are a bit similar. So we can, I don't know if you have played the game called, in Finnish it's laivanupotus, but you have this like position 1, 1. So we can then start modifying and accessing data in the data frame using these kind of addresses of the different cells in there. Cool. I think my binder is here. Everybody all set up? Okay. So let's start reading in some data and go into practice with Pandas Dataframe. Still, I already said this, but a note, so Pandas is kind of this high-level package which works on top of a bunch of other modules such as NumPy, which is then we'll probably talk a bit about NumPy later, come across it. We have some old lesson materials specifically where we use NumPy, so more kind of playing with arrays. So we can solve similar types of problems with different tools, but this year we are mainly focusing on Pandas because it's quite powerful and then intuitive to use.
Yeah, I mean, for those who are going to continue on for the Introduction to Quantitative Geology course, we will get into using NumPy a bit more there. Pandas, it's sort of going to be under the hood in a sense, so we will be using things that are parts of NumPy, but you won't necessarily know that they're parts of NumPy because it's like got a Pandas wrapper around it.
Mm-hmm.
But it's, well, as we come to things that we need to do with NumPy, we'll introduce it, but I think at the moment, at least for today, we probably won't see anything where we actually really need to like load NumPy. It would be a separate library that would be loaded and has its own kind of functions and data structures and things like this, but I don't think today that we'll necessarily need it.
Yeah, but it's good to know it exists. If you Google for Pandas documentation online, often you import both packages and you might use NumPy kind of for dealing with no data values sometimes and such. Okay, but data analysis, so we'll need some data to work with. So I'm now in CSC notebook, so there is a file, it's actually a text file called Kumpula June 2016 and so on. You can even open it and check it. So there's some metadata at the top. Dave has been modifying this at some point. And then we have kind of the data section where we have the data separated with commas. So our task would be to read this into Python and start exploring the data. So always, of course, like we're doing programming, but it's not a bad idea to actually, as a human being, open the file and check what is the delimiter, for example, because that's the first step where things can go wrong if you read the data in wrongly and you mess the columns up and such. Before starting to work, we need to import pandas. We talked about this already last week, but it's customary to import pandas as PD. So we'll do that. And afterwards, then we can refer to pandas as pd.method. Then we'll read in the data. We'll use now the read CSV function for doing that. So we will call pd.read underscore CSV. And this method will have a closer look at the documentation, but at least it needs as an argument the name of the file. You can of course start typing it in, but better option might be to copy, paste, Command C, the file name from there. And it needs to be a character string, so we need to surround it with quotation marks, single or double, it doesn't matter. I'll go ahead and run this and wait a bit that everybody's with us. So at least I don't get an error. I get something that looks like the contents of the file. Maybe a wise thing would be to store it into a variable. So I'll create a variable called data and then store the output of the PD read CSV function to that variable. So then we'll have the DataFrame object in a variable that we can start then modifying. So then as I store the output of the function to whatever it returns to a variable, then I don't get a print, then I need to print the variable separately on the screen. So there's another code cell for doing that. Okay. I guess everybody's almost at this stage. So we now used the first function related to the Pandas module, and now we are kind of getting into the point at the course where we start adding all these new modules, new function names, and it's impossible to memorize everything. Or you can of course write notes to your notebook, but often the best way is to then use a search engine, Google it, go to the official documentation and see what these functions actually eat, or so what parameters they have and what can we actually do with them. So maybe, how can I zoom in? No. Mac aid. So as you see, there's quite a lot of parameters related to this read CSV. We only gave the first value there, so we gave the file path to the file that we want to read in, and as the file was stored in the same folder as our script or the notebook, we didn't have to have like this full local data username, file name extension, so we can only call the file name. Then there's a lot of other, we could control what the separator, or so which delimiter we were using, and so on and so forth. So often if you're like, so how can I control this function? Yeah. Sorry? Okay, what does it say? Okay, so did you do this? I did that kind of after. So on the cell where you read the file, you need to have the variable name equals pd.readCSV and run it again and then print. So then you have the data stored in the data variable. Works? Yep, great. So you always need to rerun the cell if you edit anything. Okay, and then a side note that there are also then other functions for reading in data. There's a separate function for reading Excel files because they're a bit more complicated with the separate sheets and stuff. Then there's a data format called pickle. We won't introduce in this course, but it's useful if you want to store Pandas data frames, which might get messed up if you save them to a CSV file, for example. We might use that in the GIS course. Okay, but let's have a look what we have in there. So the print statements prints the contents of the data frame. It looks somewhat okay, but we have these first lines with the metadata, and then there's some NaN, so that stands for not a number, so we have some missing values at the top and also somewhere in between, so we haven't yet really fully read in the data correctly. So as we saw when we opened the data file, so there are these first lines where Dave had put some information of the file. That is quite often the case, that there's some standard structure that the first lines of the data are reserved for something else than the actual data values. So there is, among these many available parameters, there is a skip row parameter that we can give to the read CSV function when reading in the data. So let's now do that. I'll just show it to you. So let's rewrite our data variable. Data equals pd.read CSV, then paste the file name in quotation marks. So that's the first argument. Then skip rows parameter you could find from the documentation, and we have 1, 2, 3, 4, 5, 6, 8 rows to skip in the file. 8 rows of this data file don't contain the actual values.
Can I say something quickly?
Sure.
So one thing here is you might see there's only 7 lines that are commented out there, but there's also a blank line underneath that header. So we're skipping also the blank line under the header, in case you're wondering like why it's 8 and not 7.
So there you can see it better. Thank you, Dave. I'm in here. Okay, so skip rows equals 8, and then print data. That already looks like a data frame, right? So I'll wait a bit that everybody's in here. So first step, always check what is the structure of your data, read it in, and after reading it in, check that you read it in correctly. Of course, like this part, printing the data values you do when you're developing the code, then if you're super confident that it works, you don't always need to print it out, of course. But this is the first step where things can start going wrong when doing data analysis. Okay, is it okay to continue? Yeah. Okay, there's also other, like now we have 30 lines of data or so. You might have a million rows of data, so you might not always want to print the whole data frame. Of course, Python often like it doesn't show all the rows, but there's this head function. I think at least those using R are familiar with a similar syntax. So data.head by default prints the first 5 rows. So I often do that, read in the data, check the rows, and you can at the same time say, what were the column names? So rarely you memorize any of this stuff, just print it out and check. We can also check data.tail to check the last row. So sometimes, especially if you have like done a CSV file in Excel, save as comma delimited file, you might end up with some empty rows at the bottom of the file. So that might, and then if you check how many rows of data do I have, then you might get false results. So sometimes you might also want to check the head and the tail. Yeah?
One other thing is that sometimes you'll also get data files that have a footer in addition to having a header. So like you might read something in and then there's like 2 or 3 lines of just garbage at the end that if you write a script that's supposed to go through like every line of your file and do something, might then break when it hits those footer lines that you may have not recognized were there when you looked at the sort of top of the data file.
Yeah, and just a quick note, you can also define how many rows of data do you want to check. So data head 10 gives you the 10 first rows, data head 2 gives you the 2, so it gives you the kind of columns, and then it gives you the first 2 rows of data, so index 0 and index 1, right? I'll just put it back to the default value there. All right, so we have read in the data, we have checked that we read it in correctly. Then we could, like now we have this data variable, and we have already learned how to check data types of variables. So let's check, what is our data variable about? So it is a Pandas Dataframe. It has rows, it has columns, it's this 2-dimensional object basically. And then there's a bunch of methods we can use to check the properties of this data. Then there's, after this, there's a little note. I think that was also some of you mentioned in the practicals that would be nice to have this panel where you can check all the variables that are in memory. So in an IPython console, you can do this, there are these so-called magic commands. So we can type in, is it %who? And we see what variables we have at the moment in this session in memory. So we have data, and then we have PD, which is the module pandas. If we want to get some more information, you can type in whos. So then you get some kind of a table with the data type, and then some like even contents of the variable in there. So this is just a side note. You can use this while working if you find it useful. Who and whose. Okay, so we have our data frame. Let's start exploring it. And these steps are such that often, at least when I'm working, when I read the data, I often have a little code block that always does these. Print the head, print the length, check how many rows, check how many columns. So if I was expecting to have 1 million data points and I only have 10, so then I might go back and see which did I read in the wrong data file, or is my file name correct, and so on. So same thing as for lists, we can check the length of the data frame. So by default, it checks the number of rows in this data table or data frame. Of course, as it's a two-dimensional object, we might want to check how many rows, how many columns. So then we call data.shape. Oops. It's a property of the data frame, so it gives us number of rows, number of columns. We had the 4 columns, something to do with the year, then temperature, minimum and maximum values. Yeah, and indeed, maybe I went a bit quickly, so the data is from NOAA, which is the US governmental agency for atmospheric data, and then there's some metadata about the data file in the lesson materials. Yeah.
Yeah, it's a good source of data if we want to have things like temperatures in Fahrenheit that you guys can then convert to Celsius. So that's why we often use NOAA data.
Yeah.
One other thing, just to comment about the data.shape. You notice there's not the parentheses at the end of this. It's because it is an attribute of the data. So like when the data frame is created, there's a value stored for the shape that contains how many rows and how many columns are in this data file. So it can be a little bit confusing sometimes whether something is an attribute or like a method or function that is operating on a certain data type. So just, I don't know, sometimes you just type something in like that, and if you put the parentheses there and then get a syntax error, then you can remove them and you might find that like data.shape works. But shape is not a function, it is something that's kind of known about the data frame when it gets created. And I don't really know any useful tips for like how to remember those things other than just to remember them.
Yeah. So indeed, it is an object with 10 methods and some properties attached to it. All right. Then let's have a bit closer look at the labels we have in our data frame. So another kind of property, columns, we can check data.columns. So it returns this index object. So actually the column names, we have the row index 0, 1, 2, 3 by default, and then the column index is whatever names we read in from the source file from the first row. You can also call data.column.values. It gives the same information, but it's in a different data type, so it's an array of the column values. And then later on we might want to rename column names, or we might want to just get the column names and print them somewhere on a t-shirt. So this is quite a useful function, and just to remember like what columns did I have in this input file. Sometimes you might not have maximum and minimum, for example, or then you might have the mean value there, which is then the temperature. Okay, so that was the columns. Then we have the other axis, so data.index. And this looks a bit different, but it should ring a bell. We did this when talking about for loops. We used the range function. So here you can see that it's a range starting from 0, stopping at 30 at step 1. So we have an index running from 0 to 30, and this is kind of the default index. In Pandas you can also have, we could have a date time index, or you could have character strings as an index. So we'll get that to a bit later, but it's good to know that it's kind of super flexible in terms of the data types. In a Python list, the index is always an integer value, but in Pandas it could be also something else. Yeah. Okay, and then kind of to close the circle, we can call length of the index. So you notice when you call, when you ask for the length of the data frame, it's actually the length of the index by default. Then we know that the data type of the data variable is a Pandas Dataframe, right? But what are the data types of the values in the data frame? So there is another property called dtypes. Data.dtype, so it prints automatically, it checks all the columns we have, and then it prints the data type of each column. So we have one integer column where the kind of year is stored as an integer, and then we have temp, min, and max as floating point values. Yeah, so this is also useful. Sometimes you might want to then will later on convert, for example, integers to strings and so forth. So then you can afterwards check if your data type conversion went correctly. Okido. Then let's start taking some subsets. So of course, as we have a data frame with columns and rows, we can then take some subsets based on the column values, row values. So here we start with selection of columns. So let's say if you read in a massive, let's say a shape file with 100 useless columns, you can of course drop some of them while reading in the data, but you can also, while processing the data, just take a couple of the columns for further processing. So we'll again start with the data variable, and then similarly as with lists, we use the brackets, and inside the brackets we give a list of column names. So we have the kind of outer brackets and then a list for the column names, and inside there let's select the year, month, day, or the kind of date column, and then the temperature column, if we only want to continue with those. So that's the first item in the list, then a second item in the list, temp. I can at this point run this and check that it doesn't give an error. But for further use, I might want to put this into a variable. Let's call it selection. And then I can, for example, check the type. So it's still a Pandas data frame there. So if I select, it's still a two-dimensional thing. There's two columns, multiple rows this way. And this is also handy. You can also change the order of the columns. That's useful sometimes before printing out the data and so forth. Yeah. But then we can also select individual columns. So there again we have the outer brackets. In this case you can also put the brackets for the list, but that's not necessary. We can just select, give the value of the column we want to select. There we go. Okay. I jumped ahead, sorry. Let's put that to the correct place. New. Sorry for jumping around. There was still another slot for checking selection shape, for example. There. So then selecting one column was indeed the brackets, and then just the column name. So we get the values of the temp column in there. I can call that selection again, for example. Just stop me if I'm going too fast. So selection equals data temp column, and now if I check the data type of selection, it's actually not anymore a Pandas Dataframe, but it's a Pandas Series. So now we selected one column which is not anymore two-dimensional, it's one-dimensional, can of course still print it there. Just to show you, you don't necessarily have to do it. So we have the values, then we have the index, so the positions of the values in there. The values are floating point, but the object itself is a Pandas series. Pandas series, they have most of the same methods available as Pandas Dataframes, but not all of them. So sometimes you might then be like, why doesn't this work? But then you actually are working with a different data type at that point. So if you're confused, you can always then stop and check the data type of the variable you are using at that moment. Yeah. Then to add up on these different options, there's another way to access individual columns. So we could call data.temp and run that. So we get exactly the same result. And this is also a Pandas series. But this type of syntax only works if you have like kind of proper column names. So Pandas allows you to have column names, for example, with white space or some weird characters. But if you would have a white space in the column name, then you cannot use this data.column-name syntax. So that's why we recommend you to use this data, brackets, quotation marks, column names. So that works for all cases. Sometimes this might be, I don't know, nicer looking or handier. Just to highlight it here, if you see sometimes this type of syntax, it's exactly the same thing. And I don't know if there's some benefit in using this. Maybe in some pipelines it might be nicer to type it like this. Great. Okay, then getting into more on the statistics side, very basic descriptive statistics might be the first thing to do when you're starting to deal with the data frame. So let's continue a bit with this temperature column. So data temp, oops. Maybe here I can demonstrate that it's case sensitive. So if I would try this, I would get a key error. There's no such column as temp, lowercase, but there is a column called temp. And let's check the mean value for that. So there's a method called .mean, which takes all the values in one column and then returns the mean value for that. It's quite intuitive. Then again, if we would call data.mean, so the whole data frame .mean, Pandas is able to give us the mean value for all the columns now here with a kind of scientific notation, because there's no room for all the decimal values in there. Mm-hmm.
Maybe one quick comment here about this is it seems like Pandas will nicely handle things like missing data in a certain column. So like you might have noticed that there were some values for the minimum temperature or maximum temperature that were missing when we read in the data file. And you can see here like that Pandas still calculates the mean value without any problem. It doesn't sort of give like an NaN value for the mean just because there are some NaN values in the column that it's using. So this is a little bit different, like for those who will be using NumPy in the quantitative geology course, NumPy by default will give an NaN value if a column contains an NaN, and you try to calculate the mean. But here we just get nice mean values that are only for the cells that that actually have real data.
Yeah, but it's definitely good to be aware, and we'll talk more about no data values after the break. Maybe another point with this now that we call data.mean. So you notice that it did the mean calculation by default for the columns. So if you would kind of I would picture an Excel sheet, so you would then add a row below and calculate the mean kind of column-wise. You can also do things row-wise, but we'll go into that maybe later. But just to notice that these, if you apply these mean, median, min, max methods, you'll get by default the results for each column, or numerical column, I think. Might then give different results if you have character strings in the columns. Okay, so that was the mean. Then there's also this data.describe method, which prints out a table. It takes by default all the data columns and then describes some basic statistics for those. So that's quite handy. Sometimes you can clean it out a bit and put to your master's thesis. Why not? Yeah, maybe on the fly here, of course, combining with the previous thing, we could select which columns we want to include in the description. So I'll just show this, you don't have to repeat if you don't want to. Not that one, because, yeah. So we, for example, want only the temperature and then maximum value, because of course here we have this kind of this date column. So if we take the mean value of the date, I don't know if that really means a lot, at least when it's presented like this. But then you can combine these, as we learned, this selection is also a data frame. We can apply the same methods, so you can then on the fly, for example, create statistics only for a subset of the data. Okay, I guess this is rather clear. I'll just take this out because it was a bit of extra. But to remind you, if you select columns, it's the outer brackets and then a list of column names inside. There we go. Okay, that was actually the first section of Pandas. So we now learned how to read in data, how to check that we read in the data correctly, maybe skip some rows if needed, select columns, do some basic statistics, describe the data in a way. So all of this you would do even like before then going into proper data analysis. I added a little extra teaser. So there is, Dave was taking out the codes. Yeah, I had the scripts there not to have people type in. I'll just show now. You don't have to repeat. I'll show this quite quickly, but just as a teaser that as we keep saying that Pandas is so easy to use and such, we will have a full lesson on plotting with matplotlib, but already with basic Pandas methods we can create very simple plots. And I have this here linking to data exploration, because of course when you read in data, you check the statistics, you often want to just do a very quick and dirty visualization of the data. Does it look somewhat correct or expected values? So we have to run a little script to make the plots visible in the notebook, and then we can call data.plot. I'll run this. It doesn't yet look quite nice because it automatically scales the values. We want to do the plot without the year column, so I'll again do this selection with then a list of column names. So I'll have temp, then I'll have max, and then I'll have min. Again, if this is too fast, you can just watch. And here we have a nice plot. You can see the missing values there. You can see the y-axis is then the values, so it scales it automatically. You can see that, well, at least for a Finn, these values are a bit weird, so they are Fahrenheit. We'll want to convert them. and then the x-axis, it's basically the index, but as you noticed, each row of the data is for one day of the month of June in 2016. So we'll start playing a bit around more with those. And now, I don't know, maybe you get this feeling that I want to nicify that plot, add x and y axis labels and such, so wait for it, we'll do that on week 7. Then there's another additional extra section. I won't type it in here now. I hope that the scripts had been there, but you can check from the websites at the very end. So far in this course we have been working with lists, lists with data, so there are ways in which you can turn lists into Pandas objects. So if you want to check examples of that, you can find them at the end of the Exploring Data Using Pandas lesson. And then there's an example of how you could have put this exercise tree station data also into a data frame. But there are some more advanced details. We won't spend time here now doing that. Maybe as a final note, sometimes you will want to create an empty data frame to start working with. So then you can call this pd.dataframe constructor, put it into a variable, and then maybe later on you'll append things in there. But this is just to kind of show now. We'll come back to these details later. But we can also just like create a data frame without the real world data as well. Great. Yeah, that was a bit of a monologue, but do you have any questions at this point? We'll be a bit more interactive then after the break. Have some tasks for you. Yeah.
Why do you have like double square brackets? So if you look at the one where we're doing,
For example here.
Yeah.
So maybe I'll go to the spot where we did it for the first time. So in the case when you're selecting one column, you have data, then I don't know if this is a poor way of explaining it, but you remember lists. We have lists and brackets, and then you give the index value. So here we in a way treat the column names as the index value. Look at it like that. And then when selecting multiple columns, you need to give a list of the column names inside the brackets. So you kind of access the contents of the data frame inside the first outer brackets, and inside you have a list. So then the inner brackets are for the list that is the kind of value of your selection. I don't know if that was a great explanation, but so there's a list inside the kind of data frame brackets.
Yeah, maybe I can add one thing here, and that is that basically when you put something inside the first square brackets, Python expects to find basically one object there. It could be a single string of text, it could be some variable name or whatever. It expects to see one thing inside the square brackets. So if you want to have multiple columns, you have to give like one list by putting that inside a second set of square brackets. You could also like set the list up outside of the selection, like say, like selected columns, and then make a list variable there, and then when you put that into creating the selection, you could just have a single variable there, which might be a little bit less confusing in terms of the syntax. But basically it expects only to find one thing there, and if you list things outside of a list, like the two column names, just without the square brackets around them, Python would see that as two separate values.
Yeah, and we'll then go to selecting rows after the break. So let's continue at 1/2 with Pandas.
Quickly switch OBS to break screen. So I think, okay. Yeah, maybe we can continue now. So we've had a little bit of an introduction to Pandas and how things work with Pandas, and what we'll do for the second part of the lesson today is dive into our data a little bit more, learn some additional ways to process data with Pandas, and then we'll have a little overview of the lesson. We don't really have a good coding practice thing this week because we were a bit concerned about running out of time. So sorry if you were looking forward to that. Maybe at some point we'll put it on the website, but at least for right now, we don't have anything. So as you might recall, we're working with this data file that has temperature data from June 2016. We're going to continue using that same data file in this part of the exercise, but since we switched notebooks, you'll need to import Pandas again and reload the data file. So if you're now in the other notebook for the lesson, just as a reminder, there are two. So in this processing data with Pandas, that's where we're working now. And so I'm going to just import Pandas here first, and then we'll read the data file in, same as we did before. This is just a copy-paste from the earlier part of the lesson. So note that we're skipping over the top 8 rows to avoid the header once again.
Just a sec, just to demonstrate.
Yeah, that's right. And there is also now this sep in here. The default when reading in a CSV file would be to assume that it is a comma-separated text file, so CSV for comma-separated values. The assumption is that you have commas as a separator, but if you had something else like semicolons or some other character spaces, whatever, you could specify then explicitly what that separator is with the sep parameter. And as always, to make sure that we have done a decent job in reading in our data and that we have gotten what we expected, we could run something like data.head and just check things out and make sure everything looks the way we expect it to. And so far, I would say things look pretty much consistent with what we had done in the earlier first part of the lesson. So we've basically just run these top couple cells to read in the data file. Got the same kind of information that we had before, and now we're kind of in a state to continue with our data analysis. So the first thing we can do is have a look at some basic calculations, and in this case what we're going to be doing is basically adding some columns to our data frame. So as you can see here, we have our year, month, day column. That's the date column. There's temperature, which is the average temperature for that day, maximum, and then minimum temperature for each one of the days that we have here. Something we might like to do is add another column that we could use to store the difference in temperature, perhaps between the maximum and minimum, just to see, how much does the maximum and minimum temperature vary on a given day. We could do that by typing in data and then a pair of square brackets. And now we're going to give the name of a new column here called diff. And then, since nothing exists in diff yet, we're going to put an equal sign because we're going to assign some value there. And let's go ahead and just fill it in for the moment with a bunch of zeros. This is just to show you that there is the possibility, if you wanted to fill in some constant value in a column in a data frame. So, in some cases you might want to do that. And then after this, let's just print out what data looks like. So I'm just going to type both of those things into a single cell. And if we run this, we're going to create a new column in our data frame called diff. And all the values should be set equal to 0. And when we print things out here, it looks like we've succeeded in this task. So that's good. We can see here all of our data from before, and now the additional column diff that is just full of zeros. Now that's not necessarily something that's super meaningful to us, but at least that's one way in which you can fill in the values. And just to check, if we want to look at the data type, we could, for instance, look at data diff and then dot. D type. And I always mess this up and type D type, but we want D types. And we can see here, for instance, that our column contains floating point values with 64-bit precision. That's pretty much consistent with what we see. We have decimal numbers there, so no surprises. Now, if we wanted to do something like actually calculate what the difference is between the minimum and maximum temperature for the day, we can do that same sort of general process with typing data and then in some square brackets the name of the column that we're going to reference. In this case, it's diff. This doesn't necessarily need to exist in memory already. It does in this case, but it doesn't need to. And then we could say that that's going to be the difference in this case between data max, so the maximum temperature for the day, minus data min. And this now will give us something that's perhaps a little bit more interesting to look at, just how big of a difference there is between the maximum and minimum temperature. And of course, we'll then want to print out how data has changed, because now we should see the values in diff as being something different than they were before. So we can see a couple things here. If we look up on the screen, first off, when we take the difference between the maximum and minimum values, if you want to, you can sort of look at 73.6 minus 54.7 for the first column. You should see the difference is 18.9. That looks to me to be okay from here. And so it looks like our difference column does properly calculate what we want to calculate. And the other thing here that stands out is you can see that there are NaN values in here, and any place where we have an NaN in the little calculation that we're doing will then be recorded as an NaN in the value for difference. So if we try to take the maximum temperature where there's an NaN and subtract an actual value, like in the index 2, the third row there, you can see NaN minus 55.6. You get NaN as a result, because if you take some number away from something that's not a number, you still get a result that is not a number. So this is, someplace where we'll come later in the lesson to sort of removing those values, because perhaps you don't even need to bother doing this calculation. If you had millions and millions of rows in your data set, you probably want to remove the not a number values first, rather than doing all this unnecessary calculation using the NaN values. But everything here looks to be okay so far. Now, just as a demonstration of something else here, we could add a new column called diff min, where perhaps we want to take now the difference between the average temperature for the day minus the minimum temperature for the day. And basically this is the same thing we did before. We'll take temp as our reference column here, the first column that we're going to be using. So the average temperature for the day minus, outside of the square brackets, minus data, and then min. So average temperature for the day minus the minimum temperature for the day. And once again, we can print out our data frame after doing this calculation by typing print data. So this should create a new variable in new column in our data frame called diff min. And so when we print things out here, we can see that did happen. And our diff min column looks to be full of reasonably useful numbers, or at least meaningful numbers. So 65.5 minus 54.7, it's about 10. And the diff min value that we calculate is 10.8. So that seems to, again, look like our calculation has worked correctly. There are fewer NaN values here. There are fewer not a number values because we're not using the max column. The max column has more NaNs. But you can see, for instance, down at the bottom here where we do have NaN values in the min column, that again we get NaN for the diff min column that we've just calculated. So yeah, I think everything looks okay to me so far. Perhaps we can do something that's a little bit more useful, and something that probably many of you would want to do if dealing with this kind of data, And that is we can convert now the temperatures from these Fahrenheit temperatures into something in Celsius that might have some more intrinsic value to you. So we'll make a new column once again. In this case, we're going to call our column Celsius, and or maybe we can call it temp_Celsius, or temp C, whatever you want. Let's call it temp C just because it's easier to type in. And in this case, what we want to do is we want to take our values for our temperature that we have already. So I'm going to put this in parentheses because I want to take data and temp, average temperature for the day. And I want to subtract 32 degrees from that first, because when converting from Fahrenheit to Celsius, we have to subtract off this 32 degrees first, and then divide by 9/5. And I'm also going to put this in parentheses just to avoid the issue that would happen otherwise without parentheses, that we would divide this thing by 9 and then divide again by 5. So we want to divide by 9/5, or 1.8 here. This should convert our temperatures from Fahrenheit to Celsius, and then, as usual at this point, we'll print out our data frame so that we can check the temperature values. And if we run this, we see, okay, first off, we have a new column called temp C. And in our temp C column, we have some temperatures that look roughly to be the correct conversion from Fahrenheit to Celsius. A useful little trick for going between the two is 61 degrees Fahrenheit is the same as 16 degrees Celsius, so if you just flip the numbers. So we can go here, for instance, and we see where we get a temperature of 61.1, we get a temperature of 16.1, 60.9, 16.0, so it looks like things have been converted correctly. So you can use that little trick with 16 and 61 for those rare occasions when you need to deal with Fahrenheit. Also works for 82 degrees and 28. So useful information to take away from class today. So everything looks okay so far with our temperature conversion. There are no NaN values in the temperature column, so as a result, we don't see any NaN values in the converted temperatures in Celsius. So that's also good. Now, that brings us here. We're not going to let you go the whole class today without having to do something besides listen to us. So now we have a little task for you, and that is to convert our new temperature in the temp C column, or temp Celsius column if you've called it that, to the equivalent temperature in kelvins. And you might perhaps remember that 0 kelvins is minus 273 Celsius. We can put the conversion factor here on the board if you would like to convert between the two. The conversion factor itself is not really the focus, but it's more just that we want you to create a new column in your data frame called temp Kelvin, or temp K if you want to be consistent with what I was just doing here. And in that column, you should calculate temperature in kelvins.
Am I getting it right? Right? Yes?
And as you're doing this, did I turn? Okay. As you're doing this, if you have any issues, just raise your hand, let us know somehow. Woko and Lotta and myself are here and available to help if you're stuck. Sometimes we sort of, say this is a simple task, and doesn't always mean that it's totally clear, especially when you're seeing these kind of things for the first time. So how's this temperature conversion going? Is anybody done already? Yeah? So maybe like show of hands, how many people are sort of done? Okay, all right. And no, I assume from the lack of kind of crying out for help that there weren't any big issues. So yeah, probably what you've done is something like this. So we want to create a new column, data, in this case temp K, or temp Kelvin. And this is just going to be equal to our data temp C plus 273.15. And just to be good little Python users, we'll then print out our data to see when we add our new column here, our temperatures in kelvins, and these look to be roughly correct. So I think everything is okay here. Okay, that's good. So we started already in the previous lesson looking a little bit at things like sub-settings, selecting some of the data out of a data frame, and now we're going to dive into that just a little bit more by looking at how we can select data from certain rows in our data frame, from certain columns. And as it turns out in Pandas, there's quite a few different ways in which you can select your data, and depending on what you're trying to do, you'll employ one of several different possibilities. The first one looks a lot like taking index ranges out of a Python list. So we did some kind of index slicing earlier with Python lists where we took out some little piece. So we could start by creating a variable here called selection. And for our selection variable, let's just take the data from the first 5 rows of our data frame. This is basically doing the same thing as the data.head function would do. The way we can do this is pretty much consistent with how you would take a slice of values out of a Python list. So we just list here the starting index, 0, the colon character, and then the last value that should be in the slice, but will not be included, which is the 5 there. So that should give us index 0, 1, 2, 3, 4. 5 values, but remember, when you do this, just like using the range function, the last value is not included in the slice.
Actually, here it is included.
The last value is included in the slice.
So in
No,
Pandas,
it's not.
if you do this with labels or indexes, so always also the last value is included. But you will notice that soon. No, it's not. Okay. Sorry, that comes later.
Yeah.
Never mind.
So when we do the slice just using the index value, it does work pretty much the same way as the range function works and the same way as the index slices and the other things. So this is one of the things that can be a little bit confusing with Pandas and like sometimes seems a little bit inconsistent with the way some other things work in Python. So here what we see is basically our first 5 rows, just like we would expect with a slice that goes from 0 to 5 of the data. Again, if we did the data.head function, we would get exactly the same output as we see here. So we can also take another slice where if we wanted to take the, it looks like we've got differences between the comments and the text here. So we're going to go still between 0 and 5 for our index slice. So we could make another selection here, and in this case our selection could be the first 5 rows, so 0 to 5, just like we did before, but let's just take it out of a single column of our data by now including the name of one of the column headings in the data. So if we add here data 0:5, comma, and then the name of one of the data column headings, we would then get that, and if we print out our selection, we get a type error. What have I typed in wrong? Yes, I've omitted something rather important here. So when we're putting in more than just a single range of values, like just the indexes, we need to add in that we are using a sort of special syntax that we can use in these Pandas data frames, data.loc, which is going to reference location of values in a data frame, where here the first thing that is given is the rows, and the second thing then is given is the column heading. So sorry about that. It should be data.loc, and then the same stuff that we had before. And if you do this, running the cell with this small typo fixed, just to highlight it again, that's what we're typing in. We see the first 5 temperature values, and now, because we're using the data.loc, the range of index values is now inclusive. This is something that's rather frustrating to deal with, because before, when we took the slice directly from the data frame, we got the first 5 rows. Now, when we use the data.loc, I guess it's a function.
Or indexer.
Yeah, it's not. It's a little bit different than a function because we don't have parentheses around this. But when we do this, now it gives us rows 0 or values index 0 to index 5 inclusive. So you can see here that we get all 6 values in this case for the temperature column.
Just a side note, maybe it's not super clear now why here the row index 5 is included while when kind of slicing it wasn't. That's because in the first example we're kind of using these integer indexes, and in the second example we are using the axis label. So we could also have the axis labels could be A, B, C, D, E, and that in that case we could select data.loc A to C, and then C would be included. It's a slight difference, and you'll trial and error will show you which one is the correct syntax. But just to acknowledge that there are these kind of hidden differences in how to access rows in a Pandas data frame.
Yeah, in our case, since we're using index values that are basically the index labels that are the same as the normal index value for like a Python list, it's perhaps a little bit more confusing than if we had actually renamed the index to be something else. But yeah, just something to be aware of, that when we're using this data.loc, that things will operate just a tiny bit differently than they would otherwise. So what we can do though is let's just copy this down. If we take what we have here in this cell, we can just copy it and paste it down to the cell below, because of course we can take more than a single column when we do an index slice like this as well. So if we want to get temperature in Fahrenheit and temperature in Celsius, we can do that. But remember that we have to put this into a list format. So now we'll put temp C and temp in this list, and then I will have a second square bracket here at the end because we need to close off our data.loc square bracket, and again print our selection. So in this case, now we should expect to see the first 5 rows of those 2 columns, temp and temp C. Actually, first 6 rows, sorry. So index 0 through 5. And indeed, we see those values when we look at what we see in temp in our temperature slice or temperature selection here. So yeah, we can see basically how this works with selecting things, multiple columns, different row ranges. If we wanted to take rows 5 to 10, no problem. We've been working with rows 0 to 5, but we could just change that to be 5 to 10. And the nice thing, at least I find useful when you print out a Pandas data frame, is it always shows you the index over on the left side, so you also kind of get that confirmation that your slice did give you what you expected to see. Often, like with a Python list, if you print the list, you don't see the index values. So that's a useful thing that's built into the Pandas data frames that can help you if you've made a mistake somewhere see it right away. Because often, especially if you've got thousands of lines of data, you might not know the values in the data, but you might have some sense within the index range. Like especially if you've got something indexed by date, you can tell right away whether you've got the right date selection or not. All right, let's look at a couple other things here. a next one that we could look at for another selection would be that we could take a single row if we want. So if we don't want to take some range of rows, but we just want a single row and all the values, we can do that by setting our selection equal to data.loc and then just putting a number in here, so like 4. This will give us the values at index 4. We can't see index 4 right now in what's above, so let me make this go from 4 to 10 so we can at least see a few of the values. And if we print our selection, actually, you know, this time I think I won't print it. I'm just going to put the name of selection in here because we'll see something else nice. But if we take our single row and run this, all right, this comes back as a series. We see the values out of row with the index equal to 4. So now we see the year, month, day, temperature, max, min, everything from that single row. And that these values, in this case, are all listed as floating point values because they have been converted to, I think this would be a Pandas series in this case. We can check that if we want by looking at the type, if I could spell it, of selection. And so we see, for instance, here that what's returned in this case when we take a single row is a Pandas series. If we took more than a single row, like if we took data 4:5, so the index 4 and 5, and look at the type there, that's a Pandas Dataframe. Maybe I'll just also show that on the screen just by typing selection here. So whenever you're taking either a single column or a single row, what's going to come back in Pandas would be a Pandas series. And there are some limitations, for instance, to what you can do with Pandas series. Volko mentioned there might be some different methods that exist for data frames and series, so you might not be able to use all the same functions on the data. The thing here that you can see, for instance, in our data frame, the year, month, day column here is integers. All the other columns, I think, are floating point values. But when we take a single row out of here, we get a Pandas series again. When we look at the type, I didn't print that out this time. But with a Pandas series, all the data has to have the same data type. So that means our year, month, day column gets converted to being floating point numbers in this case. So maybe not the most important thing, but just something to be aware of, that sometimes there'll be some type conversions that could cause trouble.
Why does it essentially print the selection when you don't actually type print and then see selection?
Yeah, so the default behavior is like whatever would be returned when you type, like if you're in a Python interpreter and you type in like 1 + 1 and hit enter, it shows 2. Here, if you just type in the name of the variable, it will show you what the variable value is. It's basically the same as print, but with a Jupyter, like in the Python cells here, you only see the output from the last thing that was run. So if we flip this around and said like selection and then type selection, we'll only see the type and we wouldn't see the values out of the selection like we did before. If we want to see both of those things, we need to print them both. The other reason, like for just the reason that I didn't type print selection in this case here is that if you get a data frame as what gets returned for like the value of selection and you just type the name, you get this nice sort of format that Jupyter notebooks will convert the data to, because it recognizes it's a Pandas data frame, puts the headings in bold, you know, like makes it nice so that when you put the mouse over the given row, it highlights that row and things like that. Whereas if I print the selection, you get the kind of standard text format back. So sometimes I like to just type the name and not print it because you get a little bit nicer looking output. Yep. Okay. One other thing we can do here is if we want to just look at a single value from our selection. So let me go back to the case here that I was looking at before with our selection being data.loc4. So remember, that's just the values for the fourth index, so all the values for index 4. If we want to look at just a single value out of our selection, we can do that again. Like let's just look at temp, for example, by taking our selection and then giving the variable, like the column heading, basically temp. And when I run this, then I just get a single value back. Okay, so that brings us to task number 2 for this part of the lecture, and that is to find the mean temperature for Celsius for the last 7 days in June. So what you're supposed to do in this case here is just use this loc function to return the list of temperatures for the last 7 days in June, mean temperatures in Celsius. So this should be the temp C or temp Celsius column, and you should see, I don't know, 24th of June through 30th of June as the values that you get back. So you can use your knowledge of the index values and things like that to now try to get just the last 7 days of June, the average temperature in Celsius. And if you have questions or trouble with that, just let us know. So how many of you have managed to get the last 7 days of June? Anyone yet?
So you can, using the loc indexer, select the correct rows based on the kind of row number or the index, and then the temp column, so that are the mean values for those days. And if you want, you can still calculate the mean of those values using the skills we learned earlier.
So yeah, we saw in the first part of the lesson some of the methods you can use with data frames, including the one for calculating the mean value, so you can make your selection and calculate the mean of that selection if you would like. And maybe I'll just ask once again, like for show of hands, who's managed to get this data sliced? A few people? Some still working, so maybe we'll wait just a moment before we go on. Okay, so we'll have another opportunity to do another data selection in just not too long from now. So I think we'll go ahead and move on for the moment with this task. And so, yeah, the job here was basically to use this index label to select a range of values out of our data. And so our data frame here is called data, and we are going to use this .loc indexing or indexer to choose the values that we want to see in this case. So the first thing here is we want to calculate values based on temp underscore C. I'm going to put that in first just so I don't forget which column to deal with. And then the question comes, which rows or which index values do we want to deal with in this case? So it should be the 24th to the 30th of June. Those will be the last 7 days. And in that case, since our index starts at 0, that would be the first day of June. Everything's going to be shifted by 1 day off of that. So we should expect in this case for the 23rd value to be June 24th. And then the 29th value should be June 30th. And since we're using the loc indexer, or whatever Vocal called it, since we're using loc in this case, we can give those values and we should know that they will be inclusive in that. So if I run this, then I see here the 23rd, 24th, 26th, all of our values for the different indices. We see that we have 7 values here, so that part looks good. We could also print out the year or the sort of year, month, day column if we wanted to confirm. So if we wanted to make this slightly more information, we could add in here the year, as another column that would get printed out with our selection. And oops, I think I missed an end bracket here. So when I run this now with the year moda and temp C columns, I can see, in fact, like this last thing here, the last 2 numbers is the day. So from 24th of June to 30th of June. Everything looks to be okay so far in this case. Now, if you wanted to calculate then the mean value of the temperatures for the last 7 days, the way I would probably do it in the example that I have here, since I have 2 columns, is I would then in a separate line calculate selection, or maybe I'll just call this mean, and make that then selection. And the values I have in here for temp C. So I'm only going to take 1 column out of the 2 that are in my selection at the moment, and then .mean, which is the handy little method or function built in to calculate mean values. So then if I print out, instead of selection here, the mean value, first just look at the temperatures. Looks like it should be somewhere around 17 or 18 degrees for the mean value. And if we run this, then I get a mean value of 18.25. And that looks, at least as far as I'm concerned, that looks okay. So there's a few different ways you can do this. You could do it all in a single line if you wanted to, but since we took 2 columns in this case, it's a little bit easier to do this, the calculation of the mean in the second line. Yeah. Now, there are some cases where you may also want to just access a single value, and in that case, let me make sure. Yeah. So in some cases, if you want to just get a single value out of a combination of a row and a column, you can do that using a little bit different thing here. In this case, we would say data.at. And then if we give an index value, so we could say, I don't know, let's pick one. 16th day of June sounds good to me. So we'll give index 15, and then the column that we want out of our data frame, let's go with temp K. And we'll see what the temperature in kelvins was on the 16th of June, 2016. So data.at is just going to give us a single value back. Here you can see that it's 278 point blah, blah, blah. If we look at the type of what comes back from here, as expected, we just get a floating point value here. But what you can see is this NumPy thing in here. So this is our indication that NumPy is doing its stuff under the hood. In the background, we don't see it, but the value here is a floating point number with 64-bit precision using the NumPy's representation of the numbers. So just to make the point that NumPy is here doing things. There's a little extra section here about using the iloc function. I think I'll probably skip over this in the interest of time, but you're welcome to take a look at this on the lesson materials online, and we will put the examples. I guess if you go to the course webpage, you'll see the examples there of how to use the iloc function. In comparison to loc, it's basically working more like index slicing from arrays in NumPy or lists in Python, where you just give a range of like numbers of the rows. So whereas like the loc function, if you give 0:5 would give you index starting at 0 and ending at index 5 as like the labels of those rows for the index. If you did iloc 0:5, it works more like a Python list slice, that it would just give you 0, 1, 2, 3, 4, and then ignore the 5th value because it's excluded from that index slice.
Yeah, maybe just a note about all these selections and indexes and stuff. So there's different ways in which you can get the same result. So always when using these, think about the output. So first picture, oh, I want to have a selection with 2 columns and 5 rows. And then there might be like several different ways in which you can get to that result. And here is part of the toolbox for then selecting rows and columns. And there's even more to this toolkit than we are presenting in here.
Yeah.
But yeah.
Yeah.
So by testing out, was it loc or iloc or at or which index? So always test, print out the result, and confirm that the output is as you expected.
Okay, so that was our sort of slicing up the data thing in terms of looking at certain rows, certain columns, of how to kind of pick out some selection from our data. Now we're going to look at a slightly different way of dealing with things related to filtering our data, and we'll take a look at this as an example of looking for temperatures that we consider nominally to be warm days. So in this case, we would say that the days are warmer than maybe 15 Celsius, would qualify as a warm day, at least here. And in this case, we can make a new variable, warm temps. This is actually going to be a new Pandas Dataframe. And our warm temps Dataframe will contain our data at locations. So we'll do data.loc again, where our data temp C values. So I apologize if this gets a little bit busy. But what we want to do in here is we're going to use our indexer to find cases where our data temp C column has a temperature of greater than 15 degrees. So this is sort of like the logic that was used back when we were dealing with things in, I guess, when we dealt with conditional statements was probably the case where we dealt with this stuff the most so far in the course. But we just say that any place where the temperature C column has a value of greater than 15 will be selected and added into our warm temps data frame. And so we'll do that, and then we'll print out what warm temps looks like. We've got an easy thing to look for in this case, because we basically shouldn't see any case where our temp C values are below 15 degrees. So we don't have to worry about some conversion factor that we might not easily be able to understand between Celsius and Fahrenheit. But here you can look right away and you see that there are no temperatures less than 15 degrees. That looks good so far. But you can also see here over in the index column that the index values now have jumps, because the index values are carried over from the index that was assigned in in the data frame that we were taking our values from. So this would still be the first day of June, index 0, second day of June, index 1, third day of June, index 3, but then there's a jump to index 13, which is the 14th day of June. This is not the way that the indexing would work like for a Python list. Normally it would just reset things to start at 0. So this can be good because now we can trace back what position was this data in the original data frame, so that if we need to refer to that data frame, we can find our values pretty easily. We could also take this and say like, well, the second half of June looks like it's the warmer part. Let's only concern ourselves with the temperature values for the second half of June. And I'm going to copy and paste this just to make life a little bit easier, but we can copy our temperatures from our original definition of warm temps, paste them down here, and we're going to now add a second condition. And in this case, when we have two conditions, we have to add a little bit of extra stuff here. So first off, we need to put our first condition, that temp C is greater than 15, in parentheses. So I'm just going to put a space here so you can see this a little bit more easily, but we'll just put our first condition, temp C greater than 15 degrees, in parentheses. Then we can put an ampersand or an and symbol here, another set of parentheses for our second condition, and in this case we want to say that the data year moda value is greater than 2016 0615, or I guess we said greater than or equal to. So this will give us values now for our warm temps that are days where the temperature in Celsius was greater than 15 and the date, the year, month, day value is greater than 2016 0615. The reason that this particular date format is used here is because these values will always be increasing for the next day in the month. If you started with like the day first and then the month and then the year as a number value, that doesn't always increase. So you can imagine between the 9th and the 10th of June, that would be a big difference. But then for when you go to other months, things don't sort of always follow a nice pattern like that. So this again will give us a new warm temps. I think I'm maybe, yep, I'm okay with my parentheses being balanced. So then if we print out what warm temps looks like now, we see something like this. Looks pretty similar to what we saw before, but now we see only values from the dates in the second half of June, so from the 15th of June onward. So this is our slice out of our data frame for temperatures above 15 degrees Celsius for the second half of June. Obviously with this you can see that you can really start kind of drilling down into your data and extracting pieces based on a number of different conditions. This one is somewhat silly. I mean, knowing which days are warm is perhaps useful. Knowing which days are warm in the second half of the month, maybe less so, but the point is that you can do it.
Maybe Dave already mentioned it, but pay attention to the syntax here. So we did conditional statements 2 weeks ago where we used the word and for having this combination of two Boolean statements. Here we have this @ sign for the same operation. There are technical reasons for it, but if you would try to put and in there using pandas, it won't work because we have this series of data it creates. So it first checks the condition. It creates a pandas series with true and false values for the condition, and then it compares those. So it requires this kind of bitwise operator there.
Yeah.
Just to know that it doesn't work if you put the wrong word in there. And also the parentheses around the conditions are important. I bet it doesn't work correctly if you take those out. You'll be practicing this in the exercise, but just to pay attention on that slight little syntax difference in comparison to just kind of more simple conditional statements.
Yeah, so when you take out the parentheses here, I'm not getting an error necessarily. Well, I do now when I take out both of them. When I took out the first set of parentheses, I didn't get an error message, but I also didn't get the slice that I'm looking for. So I can see in here temperatures that are not above 15 degrees. Not sure that I can explain exactly why that works the way it does here, but the point is that what should be returned, or what's expected to be returned, is an array of true and false values, and so in order to get that back, you put the parentheses around the thing that's being evaluated. So yeah, we can talk about that more maybe during the exercise sessions if you're interested, or on Slack if you really want to kind of get some more information there. So one other thing that can be useful, I mean, sometimes you want to keep the original index values around, sometimes you don't, and it just really depends on the situation and kind of what data you're dealing with and how you want to process it from there. But it's possible to do the same kind of data selection that we were just looking at. We'll take the example of the first case up here where we only select temperatures above 15 degrees. So I'm just going to copy this and paste it down below here in the reset index box. So, oh, actually, okay, I think maybe there's an even easier way to do this. So let's take this as warm temps equals warm temps. And in this case, we'll do its method called reset underscore index. And then we'll add in here drop equals true. So what this is going to do is it's going to reset our index value and put it so that now it just starts at 0 and goes to however many values we have. This can be helpful, especially if we want to know right away how many numbers we're dealing with in here. And by doing this with the drop equals true, and then we maybe print out warm temps.
So if it would be drop equals false, the old index values would be stored in a column.
Yeah.
If you drop, you can just forget about the old index and reset the index from 0.
Yeah, yeah. So that's the thing that I was just trying to remind myself of by looking at the lesson materials here is that, yeah, when you use the reset index thing, just as Volko said, if you don't include the drop equals true, then the old index is still kept as another column. And in the case, I mean, most of the time, if you're resetting the index, you don't really care. So drop equals true is useful just to get rid of the old one. Okay, so now we've seen another way to do some data selection, and that is to use a condition for the values in one of the columns. So now you can do the same thing that we did before, select the last 7 days of June, but now do it on the basis of the values in the year mode column. So use something with this data.loc and then a condition to give you the values for the last 7 days of June. Your results should be the same as what you had before, but instead of using an index slice or range of index values, you should be doing it based on a test of the dates that are in the year mode column. We'll give you a few minutes to do that, and then we'll come back and continue. How are things going, folks? Anybody manage to get this selection with the range of dates or using some condition based on the year mode column? Maybe hands up if you managed to get that to work. Not as many as earlier, so are you still working on this, or are you just sort of like,
Who wants a few more moments?
yeah, okay, that's good. All right, anybody on the cusp of a major breakthrough and wants just another second? If not, let's continue here. So yeah, we're going to do the same thing we did before. We've got a variable here called selection, and we're going to use that to find the mean temperature for the last 7 days of June, using in this case a conditional statement. So as we dealt with before, we can do our data.loc. And inside here, we want to give a condition. The condition in this case is actually, we can even make this data temp underscore c dot loc, because we know we really only care about the temperatures in Celsius for that period of time. So we'll just take that single column. And dot loc, in this case, we want to say data temp underscore c greater than, oops, not temp underscore c, but year moda, greater than 2016 0614, nope, 23. So we want greater than the 23rd of June, so that should be 24th onward. And another one of those guys. And we should be in good shape here to get our selection. In this case, oops, we don't need that. So if I run this, my data.tempc is the column of the data that I'm going to deal with, and I'm going to look for locations where the year, month, day column from my data frame has a value of greater than the 23rd of June. Now, again, I don't have the values for the year, month, day column here, so I could add in year, mo, da, and some extra square brackets here to get both the year, month, day, and tempc values that meet this condition. It's a useful thing to do just to confirm the dates, especially if we're not indexing by date. And now I can see here that I've got 24th of June through the 30th, and everything looks okay here. From this point, basically we can do the same thing we did before to calculate the mean value of the temperature for that month. So then we could just take our selection and only look at the value for temp C, because we don't care about the date in this case. Let's just call this again mean. Actually, let's call it mean2. And so we do our selection temp C dot mean, and that should give us the average value of the temp C column from this selection that we can see there on the screen. And I'll print out the value of mean 2. And I just will comment out printing selection for right now. So there's our value that comes back for mean 2. And if we also wanted to check mean, or let's do it this way. Let's say mean minus mean 2. So earlier we calculated our mean value from using a range of index values. Now we've calculated using a condition on the date. It should be the same range of days. It should be the same temperature values. So the mean value, or the difference between the mean value calculated in each way, should be about 0. And just to confirm, we get back that the mean value difference between the two is exactly 0. So that's also a good thing to check and make sure our code works the way we expected it to. Not the most complicated example here, but it's always good to have confirmation that it did what it should have done.
Also makes the point that you might have had a bit different looking syntax getting the same results or the same selection. So we are getting into the part where we have different ways of achieving same results. Some might be more efficient or beautiful than the others, and then we can discuss about that.
Yeah.
But yeah.
Yep. Okay, so let's move to our next topic. We have a couple other things to hit quickly, and then we'll talk about the exercise briefly. The first one has to do with dealing with our missing data. So we've seen these NaN values, for instance, in the min column and the max column of our data frame. And oftentimes, when you read in a data file, one of the first things you want to do is clean the data. Typically, cleaning the data means removing missing values, or removing, for instance, rows of your data set that contain missing values, because if you've got missing data in there, perhaps you can't do the analysis you're trying to do row by row. So in our case, we could take our data frame and like if we look at the warm temps data frame here, we can see in our warm temps that, for instance, in the min column, we've got at least a couple missing values there. So we could take our warm temps values and then simply drop out those missing values using the drop NA method. And when you use drop NA, we can then specify which column are we going to look for the NA values in, because maybe you don't want to drop from every column that contains an NaN. But when we use drop NA, we could then say something like subset equals, and then the expectation is that you would give a list of different columns you should look at. Well, in our case, our list is going to be one column called min. So any place where there is an NaN value in the min column, and I can see people in the back sort of struggling to read this, so I'll just add a little bit extra space there. Any place that there is a missing value in the min column, we're going to drop that whole row from the data frame. So here's the before picture. So you can see that we have index 9, index 11 that both have NaN values for the min. If I run this again, we're going to get the warm temps values back on the screen a second time. But now you can see that the index 9 and index 11 have disappeared because we've dropped the rows containing the NaN values in the min column. If you want to look for multiple rows, of course, you could list more than a single column in that drop NA method when you use it. So that's a handy thing to be able to do. You can also fill values, like if you have cases where you want to replace the NaN values with some other number. There are some cases, like when you deal with GIS data, that you want to put in like the number that indicates there's a no data value for your GIS software. So sometimes that might be minus 9999. So you could look for any place where you have an NaN and then replace it with minus 9999 so that the GIS software recognizes that is a missing value and not something else. So this example that's on here would say fill the NA values with 0, but let's put in minus 9999 instead because why not? So we could then in that case say take our warm temps, and any place in warm temps will fill NA, and the value we're going to fill NA with in this case is minus 9999. So this operates a little bit differently than the drop NA, because before we were dropping values based on where we have an NaN by selecting a certain column or a list of columns, or I guess we don't actually have to select a column, it could drop any row that contains an NaN. Here with fill NA, all of the NaN values will be replaced by this value minus 9999. So earlier here when we did this drop NA, it just showed us what would happen if we were to drop out the NA values from warm temps. It didn't actually modify the warm temps data frame. So warm temps still exists here with the NaN values, and when we put in this fill NA minus 9999, you can see here that the NaN values have been replaced by the expected minus 9999. So that's just another example of how to handle missing data values. There is a very appropriate warning here about this, because this is something where you can certainly get yourself into trouble. What you're doing here is basically modifying the data. You're replacing missing values with some other number. Sometimes you want to do that, like the GIS example here. Maybe that's a useful thing because in your raster data set that you want to plot, putting in minus 9999 means that there's no attempt to try to color that cell in the data. But of course, if you're doing other things then like calculating the mean value of this column that you've now stuck this minus 9999 value into, now you're going to have trouble because the mean value would be included, so that if we did something like, I don't know why I'm doing this because we're running out of time, but if we took our warm temps, fill NA, let's just call this thing like bad underscore temps. And you can just follow along, you don't need to type this in. But if we did that where we filled in these minus 9999 values for NaNs, we could then do our bad temps temp C column, and then calculate the mean value for that. Actually, let's not do temp C because that doesn't have any missing data, but let's do min. If I calculate now the minimum or the mean value of the min column for bad temps, I now get minus 1491, which doesn't really make any sense because if I did the same calculation with instead of bad temps with our warm temps, the one where we did not replace the NaN values with some number, I then get some kind of meaningful average temperature. So the 55 degrees Fahrenheit would be the actual average of those values, excluding the NaNs. So the point is you have to be a little bit careful doing this. And I didn't mean to take so much time in saying that. There is one thing here that's also useful. I'll show you the first example just of how to do data type conversions, but won't show details about how to do the rounding and things like that. Please read the blue text here when you have a moment. But we can convert our values from one data type to another. So if we wanted, for instance, to have our temperature values, like temp C, converted to integers instead of floating point numbers, we can do that by doing something like, let's just use warm temps. And we can take warm temps, temp underscore C, and then add in this as type. And with that, we can then give some kind of thing like int. So this will convert our warm temperature values, or the temperature C values in the warm temps data frame to be integer values. And if we run that cell, again, we only see that single series out of the data set. We don't see the whole data frame, but these are the values that have been converted from floating point numbers to integer values. This is a nasty kind of thing to do because what it does is truncate the values. So like 17.9 just gets chopped off to be 17. If you want to do things like round the numbers to be something like 17.9 goes to 18, you should do that first and then convert to integers, and that's what this little blue text says above there. So that's just a word of warning because the truncation thing can get you into trouble sometimes, especially if something like 0.9 gets chopped to 0, then you might have problems where if you divide by some temperature, now you're dividing by 0 and your code breaks and you're crying and all that. So I've been there. Unique values we're going to skip over, and sorting data, it's possible to do. So you want to sort your temperatures by warmest to coldest, coldest to warmest, you could do that. And you can check the course page about that stuff because it's pretty straightforward. The one other thing that's worth noting here is that once we've done all this data frame manipulation and you've spent hours doing this stuff in Pandas, one thing you might want to do is save your data. And you want to save your data to an output file. It's really easy to do, and will generate nice output that you can easily read back into Pandas or into Excel or whatever you want. The way we would do that for our examples of the data frames we have so far is we might set some output file path. So output _fp. And let's say that this thing is equal to some file name. Let's just call it myfile.csv because I don't want to type in the actual name of what this should be. It's too long. And the way that we would then save this, is to do whatever the data frame is, so data.to_CSV, and then we can give the name of the file. In this case, it's the variable output_fp. That's going to be our file name. And then if you want to have the separator specified, you can certainly do that as well using the sep parameter. In this case, we'll just say it's separated by commas because if you write a CSV file, it makes logical sense to use commas as the separator. When you run this, that will write a file. You maybe don't see anything that happens in terms of the output here. But if we go over to our little file browser here, we can now see I have myfile.csv. And if I double click on it, one of the other things that's nice in the Jupyter Notebook system is it renders a pretty nice looking view of this data file. So you can see our index values and all the different columns and things that we've been dealing with so far in this, this lesson. You can also see missing values in here for places where we had NaNs. So, so that's nice.
Where did the output_fp come from?
This. Yeah, so this is, I mean, we could have just typed in the name of the file here in quotation marks. Sometimes when you do this, if you want to give the full file path, like, you know, in your home directory and some set of subdirectories, it's easier to label that with like a variable name and then just use that in there. You'll see all the time when you look at Python scripts that like, you'll see often like f equals this or fp equals this, which is like the name of the, whatever the file path is, and it might be like 10 subdirectories, big long string, and then putting it in here, it just makes it easier to read. Yeah, good question. Okay, so strictly speaking, we are out of time, but maybe we can borrow 5 minutes of extra time to just quickly take a look at the exercise. Sorry for running a little bit late. I thought we were doing good on time, but then we all of a sudden weren't. So here's what we have for the exercise for this week. We're basically going to continue with what you've started learning in terms of data analysis with Pandas. And there are 4 problems, 3 of which will count for points, 1 of which is optional. So problem 4, just like the week before, is an optional challenge and a fun one if you want to take that on. We have another data file here containing weather data from the National Oceanographic and whatever administration, NOAA. And you can see here the data header. This is, I mean, the sort of first 5 lines of the data file. So you can see there's headings for the data for the different columns that we have in here. There's a lot of different columns, and you can find another file there, this data 3505 doc.txt that tells you what all of those column headings mean. But you can also see that the missing values in here are designated with different numbers of stars. So that's something fun to deal with. We give you some hints about how to read that data file in, but you'll see all kinds of weird things. Like, why not just put this as commas with nothing in between? I don't know, but there's stars. Maybe it makes it a bit easier to read the data. We're going to take some piece of that and basically play around with it. So problem number 1 will be about doing some basic statistics. In this case, if the notebook renders, yep. What you'll do is you'll read in the file using pandas, like we've just seen how to do, and then you'll calculate some values based on this file. So we'll read it in, we'll look at how many rows we have, how many columns we have, and then also some things like the mean values of different columns in the data frame. So that should all be sort of consistent with what we've done in the lesson so far today. Problem number 2 involves a little bit of data selection and manipulation, so that means doing some calculations. So we make some new data frames, and our first data frame will just be certain columns that we want to take out of the bigger file that we've read in. We're going to remove the no data value, so this is the kind of cleaning step. And then after that, convert our temperatures from Fahrenheit to Celsius, because the NOAA data always comes in Fahrenheit temperatures. And then, as it turns out, this data file has temperature data for both a weather station here in Kumpula and one in Rovaniemi, so further north in Finland. And we're going to then split out our data from this one data file to be 2 separate data frames for the different stations, and then save those values to a CSV file. So that's problem 2, and again, you'll find instructions on how to do that stuff there. Once we have our data split from the 2 different stations, we can go on to problem number 3, and there, what you're going to be asked to do is to calculate just some basic statistical stuff about the data that we're dealing with. Find the median temperature for certain months. So you'll be taking out some, in this case, the data I think is from May until August of 2017. You're going to take out just the month of May, just the month of June, and do some calculations based on those for each of the 2 locations, Kumpula and Rovaniemi. And after that, you then print out some basic sort of summary statistics, and you're pretty much done with problem number 3. For those who are feeling intrepid and looking for a challenge, you can look no further than problem number 4. In this problem, the challenge is that we have data in our data file that is taken 3 times a day. So we have daily values, but it's like from the morning, from the afternoon, and from sometime later in the day. And you're being asked in this problem to combine those values from the 3 measurements per day into a single value for each day, and create a new data frame with the values for just 1 temperature measurement per day, not 3.
We haven't taught the methods you need to use for this task. We'll talk about it next week, but if you're eager to just Google for Pandas documentation, I would say the keyword is grouping data, so you can see how far you get with minimal instructions, and we'll go through them next week.
Yeah. So this is definitely, we haven't learned this stuff, and it's not an easy thing to do without a little bit of guidance. So, but for those of you, who want the challenge, it is there for you in this week's exercise. Are there any questions? I'm sure when we're 5 minutes past, no one is really wanting to ask a question, but sorry for going a little bit over today, and we'll see you in the exercise sessions on Thursday and Friday.